Alright, in this video, I'm going to go over application of first order ODE. Uh, Here, we're going to see the mechanical uh, engineering problems, which is one of the application of first ODE. So, let's see here problem. Thousands a pound object is released from rest 600 feet above the ground and allowed to fall under the influence of gravity. Assuming that the force in pound due to air resistance is negative 25 v. Here v is velocity of the object in feet per second. When will the object hit the ground? And then assume that the acceleration due to gravity is 32 feet per second square. Okay, so here 1,000 the pound object is here, let's say, and here's ground, and then the 600 feet above the ground. Okay, so we need to find out in the problem, based on the problem, we need to find out the time when the object hit the ground. So first one, we need to establish a differential equation. So using the Newton's second law of motion, F equals ma, we can build that equation. So here F represents net force. So we consider two forces acting on the object. The first one is the gravitational force, F sub g, defined by m times g, right? And then the other one is the force due to air resistance. Sometimes called damping force, resistance force. Okay. So F sub r, denoted by F sub r, is negative 25 times v. V is the velocity. So now we set v of the velocity object as unknown function. Then a net force can be then net force can be this m times v prime plus 25v is equal to mg. Okay, so put them into here. Okay, so we got ma. Okay, so here's excuse me, this should be so put negative 25v into here, and then substitute mg into fg. We're going to get this. So this is a linear equation. So in general, in general linear equation, I mean this equation can be expressed as like this, or any the damping constant, or you can say resistance constant. So mv prime plus bv equals mg. So that's a linear equation. So let me use the method of integrating factor. Okay, so then our first one to I'm going to rewrite this one as standard form of the linear equation by dividing the equation left hand side and right hand side, both sides, by m. Then we get the v prime plus b over m v equals g. So mu gonna be e to the b integral b over m, which is e to the it turns out that e to the b times t over m. So now then v of t gonna be 1 over mu times integral of g times mu, and then plus c, let's say just c sub 1. So finally we get gm over b plus c sub 1, which is constant integration, and times e to the negative bt over m. But we're going to find out x of t, because the question is to figure out the time when the ground hit, right? So we need to find out the function representing the displacement this position of the object. So we this is displacement function, or you can say position function. So to figure out the position function, we take integral of the velocity. So taking integral of this velocity of the object, then we got this. Now we're gonna plug in all the values of parameters, specify the problem into that equation, into that solution. I mean, all right. So we know the G. The problem says that 32 feet per second square, right? M. We need to figure out M. And the B is 25. And then using the initial condition, we can figure out C sub 1 and C sub 2. So first one, the problems in the problem, the pound of the object is given. The pound is a measurement of force. So force in this here, force is m times g. So the m must be pound over g. Okay, that's a you should keep in mind that. Okay, so now then m gonna be thousands over 32, and the g is 32 feet per second square, and the b is negative 20. B is 25, right? B is 25. So v of t gonna be thousands over 25 plus c sub 1 e to the negative 25t over 1000 over 32. You see, I just plug in m, g, b into the solution of the v of t, general solution I mean. So using the initial condition, initial velocity, because initially the object was still here, which means that initial velocity must be 0. So using that initial condition, v of 0 equals 0, then we can figure out c sub 1, which is negative 40. And now then we find out c2 using the initial position of that object, which is 600 feet away from the ground. So then we see here, we set the x of t as the height of the object from the rest at time t. Okay, so it means that x of 0 equals 0. Okay, so you can do either x of this, the x of t represent the height of the object from the ground. Okay, but here for me, I just set the x of t, define x of t as the height of the object from that height. So x of 0 is 0. So then C2, it turns out that C2 is negative 50. Now we set x of t equals 600 to find out when the object hit the ground. So solving that equation, then we got this one right here, right? But since look at this exponential term, since the limit of that exponential term approaches 0 as t goes to infinity, right? So we ignore that one in these terms. Okay, so then we got negative 40t minus 50 equals 600, which means that t is 16.250.